ಸ್ನೇಹ ಸ್ನೇಹ ಅವರಿಗೂ ಸಾಕಾಗಿರುತ್ತೆ. ಜಾಯ್ನ್ ಆಗಿದ್ದಲ್ಲ ಇನ್ನೊಬ್ಬ. Santosh.
Sir.
So what about only 2 students have joined the class? What about others?
I think they'll come, sir. Link they would have been seen sometime. They might come. Sir.
Okay. Okay, we'll wait for another 5 minutes.
Yes, sir.
Okay.
Sir, meanwhile, sir, internal sir paper adittu one doubt ittu.
ಹೇಳಿ. ಹೇಳಿ.
So what is PN sequence ಮತ್ತೆ ಅದು ಪ್ರಾಪರ್ಟೀಸ್ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಇತ್ತಲ್ಲ ಸರ್, ಅದು ಏನೇನು ಬರಿಬೇಕಂತ ಸರ್? ನಾವು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳಿದ್ರೆ ಏನೇನು ಬರಿಬೇಕಂತ ಸರ್, ಅದು ಗೊತ್ತಾಗ್ಲಿಲ್ಲ ಆ ಕ್ವೆಶ್ಚನ್.
ಇವಾಗ ಸೂಡೋನೈಸ್ ಸೀಕ್ವೆನ್ಸ್ ಜನರೇಷನ್ ಏನಾದ್ರು ಕೇಳಿದ್ರೆ
ಓಕೆ ಸರ್.
ಫೀಡ್ಬ್ಯಾಕ್ ಶಿಫ್ಟ್ ರಿಜಿಸ್ಟರ್ ಅದೊಂದು ಡಯಾಗ್ರಾಮು.
ಓಕೆ.
ಅದ್ರ ಜೊತೆ ಒಂದು ಟ್ರೂತ್ ಟೇಬಲ್.
ಓಕೆ ಸರ್.
ಸೊ ಹೆಂಗ್ ಜನರೇಟ್ ಆಗುತ್ತೆ ಬಿಟ್ಸ್ ಅಂತ ಸೂಡೋನೈಸ್ ಸೀಕ್ವೆನ್ಸ್ 1 ಕ್ಲಾಕ್ ಪಲ್ಸ್ಗೆ ಈಚ್ ಕ್ಲಾಕ್ ಪಲ್ಸ್. ಸೊ ಅದನ್ನ ಬಂದು ಲಾಸ್ಟಿಗೆ ಸೂಡೋನೈಸ್ ಸೀಕ್ವೆನ್ಸ್ ಏನ್ ಜನರೇಟ್ ಆಗಿದೆ ಅದನ್ನ ಬರಿಬೇಕು. ಏನಾದ್ರು ಅದ್ರ ಜೊತೆ ಪ್ರಾಪರ್ಟೀಸ್ ಏನಾದ್ರು ಕೇಳಿದ್ರೆ ಬೈ ಚಾನ್ಸ್
ಪ್ರಾಪರ್ಟೀಸ್. ಓಕೆ ಓಕೆ 3 ಪ್ರಾಪರ್ಟೀಸ್ ಅಲ್ವಾ ಸರ್?
3 ಪ್ರಾಪರ್ಟೀಸ್ ಕೇಳಿದ್ರೆ ಅದು ಲಾಸ್ಟ್ ಫುಲ್ ಡಿರೈವೇಶನ್ ಮಾಡ್ಬೇಕಂತ ಏನಿಲ್ಲ. ಲಾಸ್ಟ್ ಥರ್ಡ್ ಪ್ರಾಪರ್ಟಿ ಆಟೋ ಕೊರಿಲೇಷನ್ ಪ್ರಾಪರ್ಟಿ ಇದೆಯಲ್ಲ, ಸೊ ಅದನ್ನ ಫುಲ್ ಡೆರಿವೇಶನ್ ಮಾಡ್ಬೇಕಂತ ಏನಿಲ್ಲ. ನೀವು ಜಸ್ಟ್ ಅಲ್ಲಿ ಒಂದು ಈಕ್ವೇಶನ್ ಇದೆ ನೋಡಿ,
ಇದು ಸರ್ ಸಮ್ 1/n
ವಿಚ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 1, ಇನ್ನೊಂದು -1/l ಅಂತ ಇದೆ ನೋಡಿ. ಅದೊಂದು ಫೈನಲ್ ಈಕ್ವೇಶನ್ ಬರೆದ್ರೆ ಸಾಕು.
ಸರಿ ಸರ್.
ಮತ್ತೆ ಯಾವ್ದಕ್ಕೆ 1 ಇರುತ್ತೆ, ಯಾವ್ದಕ್ಕೆ -1/l ಇರುತ್ತೆ ಅಂತ. ಸೊ ಇವಾಗ ಸೂಡೋನೈಸ್ ಸೀಕ್ವೆನ್ಸ್ 7 ಬಿಟ್ಸ್ ಜನರೇಟ್ ಮಾಡ್ತಿದ್ದೀರಾ ಅನ್ಕೊಳ್ಳಿ.
ಸರಿ ಸರ್.
ಸೊ ಎವರಿ 7 ಬಿಟ್ಗೆ 1 ಇರುತ್ತೆ. ಸೊ ಅದರ್ ದ್ಯಾನ್ ದಟ್ ಇಟ್ ವಿಲ್ ಬಿ -1/l.
ಓಕೆ ಫೈನ್.
ನೀವು ಅದನ್ನ ಕರೆಕ್ಟ್ ಆಗಿ ನೋಡ್ಬೇಕು. PN ಸೀಕ್ವೆನ್ಸ್ ಜನರೇಟ್ ಮಾಡ್ತಿದ್ರೆ 7 ಬಿಟ್ಸ್ ಎಷ್ಟು ಬಿಟ್ಸ್ ಅಂತ. ಸೊ ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದಟ್.
ಓಕೆ ಓಕೆ ಸರ್, ಗಾಟ್ ಇಟ್ ಸರ್. ಅದು ಪೇಪರ್ ಎಲ್ಲ ಅದೇ ಸರ್, ಅದು ನೀಡಿದ ಟ್ರೂತ್ ಟೇಬಲ್ ಒಂದು, ಮತ್ತೆ ಪ್ರಾಪರ್ಟೀಸ್, ಮತ್ತೆ ವಾಟ್ ಇಸ್ PN ಸೀಕ್ವೆನ್ಸ್, ಮತ್ತೆ ಫ್ಲಿಪ್ ಫ್ಲಾಪ್ ಡಯಾಗ್ರಾಮ್ ಎಲ್ಲ ಹಾಕಿದೆ. ಸೊ ಅದಕ್ಕೆ ಸರ್ ಅದು ಗೊತ್ತಾಗ್ಲಿಲ್ಲ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಯಾವ ತರ ಬರೀಬೇಕು ಅಂತ.
ಅದೇ ಹೇಳದ್ನಲ್ಲ. ಸೊ ಏನಾದ್ರು ಅದ್ರ ಜೊತೆ ಪ್ರಾಪರ್ಟೀಸ್ ಕೇಳಿದ್ರೆ ಅದನ್ನ ಬರಿಬೇಕಾಗುತ್ತೆ. ಫಸ್ಟ್ ಸೆಕೆಂಡ್ ಎಕ್ಸಾಂಪಲ್ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಸೂಡೋನೈಸ್ ಸೀಕ್ವೆನ್ಸ್ ಗೆ ಪ್ರಾಪರ್ಟೀಸ್ ನ ಬರಿಬೇಕಾಗುತ್ತೆ.
ಓಕೆ ಸರಿ ಸರ್.
ಯಾಕಂದ್ರೆ ಬ್ಯಾಲೆನ್ಸ್ ಪ್ರಾಪರ್ಟಿ ಬೇರೆದಾಗುತ್ತೆ, ರನ್ ಪ್ರಾಪರ್ಟಿ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ಸೀಕ್ವೆನ್ಸ್ ವಾಟ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಜನರೇಟ್ ಇಟ್. ಓಕೆ
ಫೈನ್ ಸರ್.
ಅಂಡ್ ACR ಫಂಕ್ಷನ್ ಚೇಂಜ್ ಆಗುತ್ತೆ ಈಕ್ವೇಶನ್.
ಓಕೆ ಸರ್. ಯಾಕಂದ್ರೆ ಅದು ಪೇಪರ್ ನೀವು ಹೇಳಿದ್ರೆ
3 ಬಿಟ್ಸ್ ಜನರೇಟ್ ಮಾಡ್ತೀರಾ ಅನ್ಕೊಳ್ಳಿ, PN ಸೀಕ್ವೆನ್ಸ್ 3 ಬಿಟ್ಸ್ ಜನರೇಟ್ ಮಾಡ್ತೀರಾ ಅನ್ಕೊಳ್ಳಿ. ಸೊ ಅವಾಗ ಅದು ಪ್ರತಿ 3 ಬಿಟ್ಗೆ 1 ಆಗುತ್ತೆ ACR, ಮಿಕ್ಕಿದ್ದೆಲ್ಲ ಅದು -1/l ಆಗುತ್ತೆ. ಸೊ ಆತರ ಪ್ರಾಪರ್ಟೀಸ್ ಚೇಂಜ್ ಆಗುತ್ತೆ.
ಸರ್ ಅರ್ಥ ಆಯ್ತು ಸರ್. ಓಕೆ
ಕರೆಕ್ಟ್. ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ದ ಲೆಂತ್ ಆಫ್ ದಿ ಸೂಡೋನೈಸ್ ಸೀಕ್ವೆನ್ಸ್.
ಓಕೆ ಸರ್. ಈ ಪೇಪರ್ ಇಂಟರ್ನಲ್ ಪೇಪರ್ ಎಲ್ಲ ಅದೇ ಸರ್, ಸೇಮ್ ನೀವು ಹೇಳಿದೆ ಎಲ್ಲ ಬರ್ದಿದೆ, ಎಲ್ಲ ಪ್ರಾಪರ್ಟೀಸ್ ಎಲ್ಲ ಅದೇ ಬರ್ದಿದೆ ಸರ್. ಅದು 4 ಇದ್ರೆ ಒಂದ್ಸರಿ ಚೆಕ್ ಮಾಡಕ್ ಆಗುತ್ತೆ ಸರ್, ಅದು ಪೇಪರ್ ಜಸ್ಟ್ ಒಂದ್ಸರಿ
ನೀವು ಅದನ್ನ ACR ಫೈನಲ್ ಈಕ್ವೇಶನ್ ಬರ್ದಿದ್ದೀರಾ?
ಬರ್ದಿದ್ದೀನಿ ಸರ್, ಲಾಸ್ಟ್ ಪ್ರಾಪರ್ಟಿಗೆ ಅದು ಬರ್ದಿದ್ದೀನಿ ಸರ್ ಕಂಪ್ಲೀಟ್.
ಬರ್ದಿದ್ದೀರಾ ಈಕ್ವೇಶನ್?
ಎಸ್
ಆ
ಸರ್.
ಪರ್ಟಿಕ್ಯುಲರ್ ಸ್ಯೂಡೋನೈಸ್ ಸೀಕ್ವೆನ್ಸ್ ಗೆ ಬ್ಯಾಲೆನ್ಸ್ ರನ್ ಪ್ರಾಪರ್ಟಿ ಎಲ್ಲ ಬರ್ದಿದ್ದೀರಾ?
ಇದು ಹಾಕಿದೀನಿ ಸರ್, ಆ ಕ್ಲಾಕ್ ಪಲ್ಸ್ ತೋರಿಸಿ ಅದು N7 ಬಿಟ್ಸ್ ತಗೊಂಡು ಕ್ಲಾಕ್ ಪಲ್ಸ್ ಗೆ ಯಾವ ತರ ಬರುತ್ತೆ, ಶಿಫ್ಟ್ ಹೇಗಾಗುತ್ತೆ ಅಂತ ಅದು ತೋರಿಸಿದೀನಿ ಸರ್. ಅದು ತೋರಿಸಿ ಮತ್ತೆ ಜನರೇಟೆಡ್ PN ಸೀಕ್ವೆನ್ಸ್ ಅಂತ ಅದು ಬರ್ದಿದ್ದೀನಿ
ಪ್ರಾಪರ್ಟೀಸ್
ಸರ್.
ನೀವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಒಂದೊಂದ್ ಲೈನ್ ಅಲ್ಲಿ ಆ ತರ ಬರ್ದಿದ್ರೆ ನಾನು ರೆಡ್ಯೂಸ್ ಮಾಡಿರ್ತೀನಿ.
ಇಲ್ಲ ಸರ್, ಪ್ರಾಪರ್ಟೀಸ್ ಅದು ಲೈಕ್ ಇನಫ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಸ್ವಲ್ಪ ಕೊಟ್ಟು ಪ್ಲಸ್ ಆಟೋ ಕೊರಿಲೇಷನ್ ಗೆ ಅದು ಫೈನಲ್ ಈಕ್ವೇಶನ್ ಅದು ಎಲ್ಲ ಬರ್ತಿದ್ದೀನಿ ಸರ್.
ಅದು ಬರೆದ್ರೆ ಕೊಡ್ಲೇಬೇಕು. ನಾನು ಚೆಕ್ ಮಾಡ್ತೀನಿ ಒಂದ್ಸಲ.
ಒಂದೇ ಸರಿ ಅದಕ್ಕೆ 153 ಸರ್.
ಓಕೆ, 153 ಅಲ್ವಾ? ಚೆಕ್ ಮಾಡ್ತೀನಿ. ಥ್ಯಾಂಕ್ ಯು. ಸೊ ಎನಿ ಡೌಟ್ಸ್? ಏನಾದ್ರು ಡೌಟ್ಸ್ ಇದೆ ಇನ್ನು?
ಇಲ್ಲ ಸರ್, ಅದೇ ಅದೊಂದು ಡೌಟ್ ಇತ್ತು ಅಷ್ಟೇ ಸರ್, ಇಂಟರ್ನಲ್ ಪೇಪರ್ ಇಲ್ಲ ಸದ್ಯಕ್ಕೆ ಅದೊಂದು ಡೌಟ್ ಇತ್ತು.
ಓಕೆ, ಐ ವಿಲ್ ಚೆಕ್ 153.
Yes.
So shall I start the session?
Thank you, sir.
Okay, thank you. So last class we discussed about ASK, the generation of ASK signals, and we discussed about the signal space diagram and receiver diagram, coherent detection of binary ASK waves also we have discussed last class, and the probability of symbol error calculation when symbol 1 is transmitted, that one we have done. So now we need to discuss about symbol 0. We need to discuss when symbol 0 is transmitted, what is its corresponding probability error equation. We need to check. This is the probability of error when symbol 1 is transmitted. So this equation we discussed last class, right? So now let us now assume symbol 0 is transmitted. When symbol 0 is transmitted, so this x1 is nothing but it is observation value or test statistics, right? Which is the output of your, here you can see, which is the output of your integrator, or you can see a correlator output is x1, right? So correlator consists of one multiplier and a low pass filter or an integrator. We also call it as integrator. The output of the correlator is the observation value or test statistics, and this is sampled at every t is equal to tb. You will get some observation value, so that can be denoted as x1, and that needs to be compared with your threshold voltage VTH, so in order to receive the proper output. If x1 is greater than VTH, symbol 1 will be received. If x1 is less than VTH, then symbol 0 will be received. Next. So the x1 is equal to, we can write 0 to tb x of t pi 1 of t into dt, right? Here what happens, 0 to tb, because when symbol 0 is transmitted, machine means no information it is being transmitted, so noise will be present at the receiver along with that information 0, right? So w of t directly we can write pi 1 of t into dt, which is equal to w1. Then what is the expected value of Gaussian random variable x1? So which is 0, and variance of the Gaussian random variable n0 by 2. Then the conditional probability density function.
Screen presentation idagilla ante sir, screen
ಸ್ಕ್ರೀನ್ ಕಾಣಿಸ್ತಾ ಇಲ್ವಾ ನಿಮಗೆ? ಓಕೆ ಓಕೆ,
ಇಲ್ಲ ಸರ್, ಅಲ್ಲ ಅದು ನೋಡ್ಬೋದು.
ಥ್ಯಾಂಕ್ ಯು. Now?
Yes sir, now it is visible.
Yes. So now you assume symbol 0 is transmitted, then we need to derive the equation for probability of error calculation. We need to do it when symbol 0 is transmitted. This x1 is the observation value or test statistics, and which is the output of your correlator at the receiver. Correlator means it consists of one multiplier and an integrator. Integrator is nothing but a low pass filter. So output of the correlator, you will get the x1, which is observation value after each sample. When you do the sampling for every one symbol duration, so you will get the observation value or test statistics, which is x1. So when it is integrated 0 to tb x of t pi 1 of t dt, here x of t you will get w of t. W out of t means when 0 is transmitted, no information it is being transmitted, right? So it consists of a noise, additive white Gaussian noise, that can be denoted as w of t pi 1 of t dt, which is equal to w1. Then the expected value of this Gaussian random variable w1, so which is 0. So variance of this Gaussian random variable w1, which is n naught by 2. Hence the conditional probability density function of Gaussian random variable, which is x1, when symbol 0 is transmitted, we can write this equation. So you already know, I think, how to write this equation here, which is equal to 1 by root 2 pi into variance. Variance we got n naught by 2. Next, exponential minus 1 by 2. x1 is the observation value when symbol 0 is transmitted, x1 minus 0 whole square divided by n naught by 2. So after doing that cancellation and all, you will get this term, this equation you will get, which is 1 by root pi n naught exponential minus x1 by root n naught whole square. Next, probability of error p of 0, which is equal to p of x1 should be greater than root eb by 2 when symbol 0 is transmitted. Then that results in error, right? So in which region it falls? If x1 is greater than root eb by 2, in which region it falls? It should be interactive session, right? So in which region it falls? When you are finding the equation for p of 0, right, you have to assume that x1 falls in the region z1. Understood? Region z1. So when it falls in the region z1, then what is x1? x1, it should be greater than root eb by 2, right? x1, it should be greater than root eb by 2. So it falls in the region z1 when you have assumed symbol 0, which one we are going to transmit it. Next, the limits you can write root eb by 2 infinity f x1 of x1 by 0 d x1. So just substitute this equation, conditional probability density function, you just substitute it, so you will get this equation. Now let y is equal to x1 by root n naught, and when you differentiate this with respect to x1, then dy is equal to dx1 by root n naught. If x1 is equal to infinity, then y it becomes equal to infinity, right? if x1 is equal to root EB by 2, then y it becomes equal to 1 by 2 root EB by n naught. Just substitute this x1 in this equation. You will get this equation, right? Next, change the limits. So it is 1 by 2 root EB by n naught to infinity, right? Then 1 by root pi. So this becomes exponential minus y square. Then what is dx1? dy into root n naught. When dy root n naught, if you substitute this root n naught and so one more root n naught, it gets cancelled. So you'll get 1 by root pi. So then divide and multiply by it by 2. Then you will get 1 by 2 into 2 by root pi integration 1 by 2 root EB by n naught to infinity exponential minus y square dy. So this is called complementary error function. So ERFC of 1 by 2 root EB by n naught. So this equation P of 0, whatever the equation we got, we can compare with the equation what we got for P of 1. So we got P of 1 equation, this is the equation we got. P of 1 is equal to 1 by 2 ERFC of 1 by 2 root EB by n naught. So both equations are same. Both equation, if you compare it, both equations are same. Then the average probability of symbol error, each having equal probability. So we can write PA is equal to 1 by 2 P of 0 plus, because it has equal probabilities. Symbol 0 and symbol 1, its probability. Then we can substitute the equation of P of 0 and P of 1 in this equation. We'll get finally ERFC. If you solve, you will get 1 by 2 root EB by n naught. We know that P of 0 plus P of 1 is equal to 1. Then average probability of symbol error is P is equal to P of 1 is equal to P of 1 into P of 1 plus P of 0 into P of 0. So because it has half probability, after doing calculations, you will get this equation. So if they ask the problem to find out the average probability of symbol error, you have to use this equation. Understood? This one understood? Symbol 0. Probability of error when symbol 0 is transmitted. What about Sneha?
ಐ ಥಿಂಕ್ ಅವ್ರು ಮಾತಾಡ್ತಿದ್ದಾರೆ, ಬಟ್ ಸಮ್ ನೆಟ್ವರ್ಕ್ ಇಶ್ಯೂ ಇಂದ ಅದು ವಾಯ್ಸ್ ಕೇಳಿಸಿಲ್ಲ ಅನ್ಸುತ್ತೆ.
ರೋಹಿತ್.
ಹಲೋ.
ರೋಹಿತ್.
ಸರ್ ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಸರ್. ಸರ್ ಇದು ಅರ್ಥ ಆಯ್ತು ಸರ್ ನೀವು ಹೇಳಿದ್ದು.
ಪಿ ಎಫ್ 0 ಅರ್ಥ ಆಯ್ತಾ?
ಅರ್ಥ ಆಯ್ತು ಸರ್.
ನೆಕ್ಸ್ಟ್ ಕಂಟಿನ್ಯೂ ಮಾಡ್ಲಾ?
ಸರ್ ಒಂದು ಡೌಟ್ ಇದೆ ಸರ್. ಅದು ಎಸ್ಟರ್ಡೇ ನೀವು ಆನ್ಸರ್ ಸ್ಕ್ರಿಪ್ಟ್ ನ ಮಾರ್ಕ್ಸ್ ಹಾಕಿದ್ರಲ್ಲ,
ಹೇಳಿ.
ಸರ್ ಅದಲ್ಲಿ ನಂದು 3rd ಕ್ವಶನ್ ಮತ್ತೆ 8th ಕ್ವಶನ್ಗೆ 2 ಮಾರ್ಕ್ಸ್ ಕಟ್ ಆಗಿದೆ. ಅದು ಎಲ್ಲಿ ಕಟ್ ಆಗಿದೆ ಮತ್ತೆ ಆ ಫೈನಲ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಯಾವ ತರ ಬರೆದ್ರೆ ಕರೆಕ್ಟ್ ಆಗಿ ಮಾರ್ಕ್ಸ್ ಬರುತ್ತೆ ಅನ್ನೋದು ಗೊತ್ತಾಗಬೇಕಾಗಿತ್ತು ಸರ್.
ಅದು ಸ್ಕೀಮ್ ಪ್ರಿಪೇರ್ ಮಾಡಿ ಕಳಿಸ್ತೀನಿ. ಸೊ ನಿಮ್ದು ಇಯರ್ಸ್ ಏನ್ ಹೇಳಿ?
142 ಸರ್.
142. ಆಯ್ತು, ಚೆಕ್ ಮಾಡ್ತೀನಿ.
ಓಕೆ ಸರ್. ಅದು 3rd ಒನ್ ಅದು ಆಲ್ಮೋಸ್ಟ್ ಎಲ್ಲ ಪ್ರಾಪರ್ಟೀಸ್, ಅದು ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಪಿ ಎನ್ ಸೀಕ್ವೆನ್ಸ್ ಮತ್ತೆ ಲಾಸ್ಟ್ ಕ್ವಶನ್ ಸರ್.
ಪ್ರಾಪರ್ಟೀಸ್ ನೀವು ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟೆ ಬರ್ದಿದ್ದೀರಾ?
ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟೆ ಬರ್ದಿರೋದು ಸರ್.
ಸೊ ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟು ಬರ್ದ್ರೆ ಫುಲ್ ನಾನು ಕಟ್ ಮಾಡಿರಲ್ಲ ಅನ್ಕೊಳ್ತೀನಿ.
ಅದು ಎಲ್ಲ ಬರ್ದಿದ್ದೀನಿ ಸರ್.
ಅಲ್ಲ, ಪ್ರಾಪರ್ಟೀಸ್ ಬರೀ ಪ್ರಾಪರ್ಟೀಸ್ ಬರೆದ್ರೆ ಅಲ್ಲ, ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಸೂಡೋ ನೈಸ್ ಸೀಕ್ವೆನ್ಸ್ ಜನರೇಟ್ ಆಗಿರುತ್ತಲ್ಲ, ಸೊ ಅದನ್ನ ಇಟ್ಕೊಂಡು ನೀವು ಪ್ರಾಪರ್ಟೀಸ್ ನ ಡಿಸ್ಕ್ರೈಬ್ ಮಾಡಬೇಕು.
ಅದ್ ಮಾಡಿದೀನಿ ಸರ್.
ಅದನ್ನ ನೋಡ್ತೀನಿ, ಅದನ್ನ ಚೆಕ್ ಮಾಡ್ಬೇಕು ನಾನು. ನಿಮ್ದು 142 ಅಲ್ವಾ?
142 ಸರ್.
ಪಿ ಎನ್ ಸೀಕ್ವೆನ್ಸ್ ಪ್ರಾಪರ್ಟೀಸ್ ಮತ್ತೆ ಅಲ್ಲಿ ಮೋಸ್ಟ್ಲಿ ಏನಾದ್ರು ಇರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು
ಇದು 8th ಕ್ವಶನ್ ಸರ್, ಲಾಸ್ಟ್ ಕ್ವಶನ್.
ಇದು ಥರ್ಡ್ ಅಲ್ವಾ?
ಇದು ಥರ್ಡ್. ಲಾಸ್ಟ್ ಒನ್ ಬಂದ್ಬಿಟ್ಟು 8th ಒನ್ ಸರ್.
ಮ್ಯಾಚ್ ಫಿಲ್ಟ್ರಾ?
ಇದು ಮ್ಯಾಚ್ ಫಿಲ್ಟರ್ ಸರ್.
ಮ್ಯಾಚ್ ಫಿಲ್ಟರ್ಸ್. ಓಕೆ, ಆಯ್ತು
ಸರ್. ಅದೇ ಮ್ಯಾಕ್ಸಿಮಮ್ ಲೈಕ್ಲಿಹುಡ್ ಡಿಕೋಡರ್, ಅದೇ ಸರ್ ಲಾಸ್ಟ್ ಕ್ವಶನ್.
ಓಕೆ ನೋಡ್ತೀನಿ.
ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.
See, binary PSK, all of you just try it, binary PSK. So this is the mathematical equation and all I will explain you. The product of error calculation you do it. So in binary PSK, the transmitted signal S of t, it can be defined as S1 of t is equal to root 2 EB by TB cos 2 pi FCT for symbol 1. For symbol 0, it becomes minus root 2 EB by TB cos 2 pi FCT. So S1 of t has 0 phase shift. S2 of t has 180-degree phase shift. Right? Understood? So S2 of t has 180-degree phase shift. S1 of t is nothing but there is no phase shift for symbol 1. So EB, TB, all those things you know. So that carrier frequency FC is equal to NC by TB. So NC is nothing but number of cycles which is been passed in 1 bit duration, 1 symbol duration. So that decides your carrier frequency. Next, this pi1 of t, basis function. So that can be written as, you know already this equation. Next, after substituting this equation, carrier signal equation in this modulated wave, modulated equation for PSK modulated wave. So if you substitute this pi1 of t, then you will get S1 of t is equal to root EB pi1 of t for symbol 1. Then S2 of t is equal to minus root EB pi1 of t for symbol 0. So a pair of signals that differs in phase by 180-degree are called antipodal signals. Right? So can you tell me how do you generate a BPSK signal? Whether you need a mux or demux, how you are going to generate it? Anyone? So mux means how you are going to generate it. You can unmute it and you can speak with me. How you can generate? You have suppose 2:1 mux you are using. So using 2:1 mux, how you can generate the BPSK signal? Rishu?
Yes, sir.
Why you joined late?
I saw the message late.
Can you tell me that how you can generate the BPSK signal is using 2:1 mux?
So, hello?
Tell me.
I don't remember now.
Santosh?
That block diagram I had to check, sir. I forgot. I had to check ಮಾಡ್ಬೇಕು sir once again.
ಇಲ್ಲ ನೀವು 2:1 ಮಕ್ಸ್ ಯೂಸ್ ಮಾಡಿ ಸೊ ಯಾವ ತರ BPSK ಸಿಗ್ನಲ್ ನ ಜನರೇಟ್ ಮಾಡಬಹುದು. ಸೊ BPSK signals we call it as antipodal signal, right?
Yes, sir.
It has how many phase shifts? ಎಷ್ಟು ಫೇಸ್ ಶಿಫ್ಟ್ ಇರುತ್ತೆ ಅದರಲ್ಲಿ?
Antipodal signal ಗೆ sir, I think 2, sir.
ಒಂದು 0 ಡಿಗ್ರಿ, ಇನ್ನೊಂದು 180 ಡಿಗ್ರಿ ಫೇಸ್ ಶಿಫ್ಟ್ ಇರುತ್ತೆ, ಕರೆಕ್ಟಾ?
Yes, sir. Yes. ಕರೆಕ್ಟ್.
ಸೊ ನೀವು ಇನ್ಪುಟ್ ಏನ್ ಕೊಡ್ತೀರಾ 2:1 ಮಾರ್ಕ್ಸ್ಗೆ? ಇನ್ಪುಟ್ಸ್ ಏನ್ ಕೊಡ್ತೀರಾ? ಎಷ್ಟು ಬೇಕಾಗುತ್ತೆ? ಸೊ 2:1 ಮಾರ್ಕ್ಸ್ ಮೀನ್ಸ್
2 ಇನ್ಪುಟ್ ಅಷ್ಟೇ.
2
ಅದೇ 2
ಇನ್ಪುಟ್ಸ್
ಫೇಸ್.
ಇರುತ್ತೆ, 1 ಸೆಲೆಕ್ಟ್ ಲೈನ್ಸ್ ಇರುತ್ತೆ. ಓಕೆ,
ಹೌದು ಸರ್.
means 2 inputs. So what you will give 2 inputs? Select line is nothing but your modulating signal, right?
The binary sequence, 2 inputs will be the binary sequence with the two-phased phase shifted.
ಇಲ್ಲ, ಇದು ಸೆಲೆಕ್ಟ್ ಲೈನ್ಸ್. ಸೆಲೆಕ್ಟ್ ಲೈನ್ ಏನಿರುತ್ತೆ? ಇನ್ಪುಟ್ ಬೈನರಿ ಸೀಕ್ವೆನ್ಸ್ ಇರುತ್ತೆ, ರೈಟ್?
Yes.
ಇನ್ಪುಟ್ ಬೈನರಿ ಸೀಕ್ವೆನ್ಸ್ ಇರುತ್ತೆ. ಸೊ ಇನ್ಪುಟ್ 2 ಇನ್ಪುಟ್ ಇರುತ್ತಲ್ಲ, ಅದೇನಿರುತ್ತೆ? 1 ಇನ್ಪುಟ್ 0 ಡಿಗ್ರಿ ಫೇಸ್ ಶಿಫ್ಟ್ ಇರುತ್ತೆ,
180 degrees.
180 ಡಿಗ್ರಿ ಫೇಸ್ ಶಿಫ್ಟ್ ಇರುತ್ತೆ. ಸೊ ಹೌ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸೆಲೆಕ್ಟ್ ಇಟ್, ಈಚ್ ಇನ್ಪುಟ್? ಫಸ್ಟ್ ಇನ್ಪುಟ್ ಏನ್ ಕೊಡ್ತೀರಾ? ಫಸ್ಟ್ ಇನ್ಪುಟ್ 0 ಡಿಗ್ರಿ ಫೇಸ್ ಶಿಫ್ಟ್ ಕೊಡ್ತೀರಾ, ರೈಟ್? ಸೆಕೆಂಡ್ ಇನ್ಪುಟ್ 180 ಡಿಗ್ರಿ ಫೇಸ್ ಶಿಫ್ಟ್ ಕೊಡ್ತೀರಾ. ಸೊ ಹೌ ಡು ಯು ಲಾಕ್ ಅಂಡ್ ಅನ್ಲಾಕ್ ಕಾನ್ಸೆಪ್ಟ್, ಹೌ ಡು ಯು ಯೂಸ್ ಇಟ್? ಇದನ್ನ ಶಿಫ್ಟ್ ಕೀಯಿಂಗ್ ಅಂತ ಹೇಳ್ತೀವಿ ತಾನೆ, ಇದನ್ನ ಫೇಸ್ ಶಿಫ್ಟ್ ಕೀಯಿಂಗ್.
ಹೌದು ಸರ್.
ಸೊ ಲಾಕಿಂಗ್ ಅನ್ಲಾಕಿಂಗ್ ಇಯರ್ ಆಲ್ಸೋ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಬರುತ್ತೆ, ಕೀಯಿಂಗ್.
ಓಕೆ ಸರ್.
ಸೊ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ? ಸೊ 1 ಸೆಲೆಕ್ಟ್ ಆದ್ರೆ ಫಸ್ಟ್
one of them 0 sir. And it's a 0 ಗೆ I think one if it is 0, one of the phase shift that is 0 degrees will be selected. If it is 1 ಅಂದ್ರೆ select
1 ಅಂದ್ರೆ 0 ಡಿಗ್ರಿ ಫೇಸ್ ಶಿಫ್ಟ್ ಸೆಲೆಕ್ಟ್ ಆಗುತ್ತೆ.
0 ಅಂದ್ರೆ 180 degrees.
180 ಡಿಗ್ರಿ ಫೇಸ್ ಶಿಫ್ಟ್ ಸೆಲೆಕ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ಇದು ಜಸ್ಟ್ ಪಾಸ್ ಆಗುತ್ತೆ ಅಷ್ಟೇ.
Yes,
ಸೊ ಕಂಟ್ರೋಲ್ ಮಾಡ್ತಿರೋದು ಸೆಲೆಕ್ಟ್ ಲೈನ್ಸ್ ತಾನೆ.
ಹೌದು ಸರ್.
ಸೊ ಅದಕ್ಕೆ ಅದನ್ನ ಕೀಯಿಂಗ್ ಅಂತ ಕರಿತೀವಿ ನಾವು, ಕೀ ತರ.
ಓಕೆ ಸರ್.
ಫೇಸ್ ಶಿಫ್ಟ್ ಕೀಯಿಂಗ್.
ಅರ್ಥ ಆಯ್ತು ಸರ್. ಓಕೆ.
ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ದಿಸ್ ದ ಸಿಗ್ನಲ್ಸ್. ಟೆಲ್ ಮಿ
ಬೇಸ್ಡ್ ಆನ್ ದಿ ಟಾಪಿಕ್ಸ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಏನೋ ಸ್ವಲ್ಪ ಸಾಲ್ವ್ ಮಾಡಕ್ಕಾಗುತ್ತೆ ಸರ್, ಎಕ್ಸಾಂಪಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್
ಇದ್ರಲ್ಲ.
ಎಸ್ ಸರ್.
ಇದು ನಾನು ತುಂಬಾ ಬೇಕಾದ್ರೆ ಮಾಡಿಸ್ತೀನಿ, ತುಂಬಾ ಇದಾವೆ ಪ್ರಾಬ್ಲಮ್ಸ್. ಸೊ ಜಾಸ್ತಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ಸಾಲ್ವ್ ಮಾಡೋಣ ಅಂದ್ರೆ ಬೇಕಾದ್ರೆ ಮಾಡೋಣ ಸಾಲ್ವ್ ಜಾಸ್ತಿ ಪ್ರಾಬ್ಲಮ್ಸ್. ಓಕೆ,
yes sir, problems tools is more problems after this.
ಆಯ್ತು, ಡೆಫಿನೆಟ್ಲಿ ಐ ವಿಲ್ ಡು ಇಟ್. ಓಕೆ, so this is the signal space diagram or constellation. It is also called as constellation diagram. You remember this? So we call it as one dimensional constellation diagram or signal space diagram. In exam, instead of signal space diagram, they may ask draw the one dimensional constellation diagram for binary PSK, binary ASK, like that they will ask, right? You have to remember. So this is the one dimensional signal space diagram. So anyone, can you explain? So how to draw this one dimensional signal? How many points are there? 2 message points are there, right? If first message point is S1 is equal to root EB, and the second message point is S2 is equal to minus root EB. It is minus root EB, not down. Minus root. Then what is the midpoint between these two? Plus root EB and minus. Suppose S1 is equal to 1, S2 is equal to minus 1. Then what is the midpoint? Is 0, right? So if an integer range, if it is given plus or minus 2 integer range, then what is the midpoint between plus 2 and minus 2 is 0. Here also, so between root EB and minus root EB, the midpoint between these two message point is 0. It's called decision point. So we call it as threshold voltage, VTH voltage. So when the observation value x1 falls in region Z1, then symbol 1 will be received. When the observation value x1 falls in the region Z2, then symbol 0 will be received. Same thing. So this is the generation of binary PSK waves. So M of t is the modulating signal, a binary stream of data, which one you are going to transmit it. So that has to be represented using non-return to zero polar format. That will be given as input your multiplier, and one more input will locally generated carrier signal, which is pi 1 of t. Not this is a generation. We are speaking about generation. One is modulating signal and one more is carrier signal, pi 1 of t, which is equal to root 2 by tb cos 2 pi fct. The output of this multiplier, you will get a binary PSK wave. So this is the input stream of data. One, suppose 1 and 0 you are transmitting. So 1 you can represent it as root EB, and 0 is minus root EB. Why you need to represent this one using binary polar format? NRZ, what is the use of representing this using binary polar, NRZ polar instead of unipolar? What is the use? Tell me. Rohit?
Yes, sir.
Why? Why we are
Hello.
using? Tell me.
Sir, network issues.
Network issue. Okay.
Uh,
So why we are using NRZ polar format in the case of binary PSK instead of unipolar NRZ?
Sir, like we require both 1 and 0, with the phase shift of 180 degree. No, sir. That's it.
Because of 180 degree phase shift.
Yes, sir.
Correct. So this is the carrier signal at the transmitter. So for symbol 1 will represent the modulated wave as S1 of t, and for symbol 0 will represent modulated wave as S2 of t. So S1 of t, it has 0 phase shift when symbol 1 is transmitted. Here when you are going to transmit symbol 0, you can see it is reversed by 180 degrees. So 180 degree phase shift is present. Next, coherent detection of binary PSK waves. So already for ASK we have discussed. There we used the VTH is equal to root EB by 2. Here the midpoint between the two message point is 0. So you can keep that threshold voltage VTH is equal to 0. The X1 need to be compared with this. If X1 is greater than 0, symbol 1 will be received. If X1 is less than 0, symbol 0 will be received. Next, we look at the probability of average error calculation, symbol error calculation. We assume initially that symbol 1 is transmitted. Then all of you do it, solve this. Solve this, you assume symbol 1 is transmitted. First, write down the conditional probability density function, and you let me know what equation you will get for binary PSK. Conditional probability density function. Equation, you let me know what you will get. You assume symbol 1 is transmitted. Take 2 minutes time and let me know the answer.
So first you implement this. See how to implement this equation first. So when you expand this, what is the first one you will get? Is it W0 of the power of this second term is 1. So
All of you are trying.
So since we have n billion terms, focus of time on the n billion terms. So just take this first R of n passes through a delay element. It will just like Z inverse also here. All that means delay. So output of the net delay is R of inference.
Rishu, are you trying? Revant?
Sir, trying, sir.
Okay.
Now all these outputs are that is output of the magic filter. They are multiplied with coefficients. First term here is first term here. This part here. Not of n. First coefficient. Then second term is then the last one is so once you multiply your another equalizer values with output of the mathematical, so then all the terms you need to add here to get determine and zero. Multiply all the terms. So here the summation and also relates to the sequence that is your that is compared with your actual signal, actual transmitted signal is your reaction. It's another your error signal. So what is the expression of error signal? Here it is. Reaction is equal to actual transmitted signal reaction minus the detected signal, which is step of is what here. So now based on this error signal, the values are updated. Now use the summation here. Now it's a relay transmitter and receiver in a tiny mode. It counts transmitted data are your final highlight or the signal. So now that can be compared with the data signal. Now based on this error signal, weights are so this is how the procedure followed in order to equalization or using the to minimize now let us consider numerical examples. So in this given problem, we will just Remember, the first order equalizer to be designed.
So you just go through this. So for x1, you got x1 is equal to root EB plus W1.
Equalizer is designed using a diagram where the desired sequence is what
And then expected value you calculate, you will get root EB, and variance of Gaussian random variable x1 you will get n0 by 2. Then you calculate the conditional probability density function of Gaussian random variable.
equalizer coefficients.
What equation you will get? Let me know.
Also assume that system is causal. So what is saying is causal means you will start with zero. Just for a causal system, it's an output is zero. And assume that equalizer initial coefficient is zero. So monitor coefficient or also we are given that the convergence constant of size is now let us see how we can compute.
Variance is n0 by 2.
Huh?
Variance n0 by 2.
What equation you will get?
Now first this right
You tell me that equation for conditional probability density function. Fx1 of x1 when symbol 1 is transmitted /1, which is equal to 1 by root 2 pi. This much time is required.
Into exponential of x plus root minus e0 by n0 root n0 whole square.
What?
Negative exponential of minus root EB by n0 whole square.
Correct. So you got this equation?
Yes,
Correct.
sir.
x1 minus root EB by root n0 whole square. Exponential minus 1 by root pi n0. So next, probability of error when symbol 1 is transmitted. When symbol 1 is transmitted, x1 to get the error, x1 it should lie in the region. It should lies in the region Z2, right? It should fall in the region Z2. Then x1 should be less than 0 when symbol 1 is transmitted. So this is you write the limits minus infinity to 0 for region Z2. For region Z2 it is minus infinity to 0. Next, you just substitute that conditional probability density function equation. So you assume that this let y is equal to x1 minus root EB by root n0. So you will get dy root n0, which is equal to dx1. So if you differentiate with respect to x1, you will get this equation. So first you consider x1 is equal to minus infinity. And you substitute in this equation, you will get x1 is equal to, if x1 is equal to minus infinity, y is equal to minus infinity, you will get. If x1 is 0, you will get y is equal to minus root EB by n0. So in these limits, you just substitute it. So you will get exponential minus y square. dx1 is nothing but dy root n0. Root n0, it gets cancelled. So you will get 1 by root pi. Minus infinity minus root EB by n0. Exponential minus y square dy. So you will get the symmetric function. Since the function 1 by root pi exponential minus y square is even symmetric about y is equal to 0, the two shaded areas are equal. So finally, we can write this one also. This equation also we can write it as root EB by n naught to infinity exponential minus y square dy. So finally, divide and multiply by 2. You will get the complementary error function. So this is the equation you will get for probability of error when symbol 1 is transmitted. So next, in your home, you just work on P of 0. Find out the equation. You will get P of 0 also, same equation you will get. 1 by 2 ERFC of root EB by n naught. Then calculate the probability of average error calculation, P. Right? So in your home, what you should do? You have to assume symbol 0. P of 0 equation you find out. Then you calculate the probability of average error calculation, P. Right? Understood? Then I will stop this session. So if you have any queries, you can ask me.
Sure, I have doubts.
Tell me.
So like recording internals, that was.
Which one? The internal. Tell me.
Internals, second question I wrote correct, but I got this. It was numerical, sir. All correct.
That one second question. No, why I have reduced marks? Some students have written direct answer.
So no, sir. Like I can share my screen. I have answer sheet. I will show you 1 second.
No. Second. What they have done,
Share my screen. Yes, sir. I reduced everything.
Direct answer they have written for pi 1 of t, pi 2 of t, and they have not.
I derived from graphs and all. I will show you the thing if you allow me.
Okay, show me.
1 second, sir.
Or else you just tell me your ESL number. I will check.
1 by 17 is 137.
130?
137.
137. Okay, I will let you know.
Like 1 second, sir. So can you see? Excuse me, sir.
Come down.
Yes, sir.
How many 4 marks have you given?
Yes, sir. I reduced
4 marks.
Yes, sir.
So wait. Up you go.
Yes, sir.
Come down.
Yes, sir. This is basic equation.
Here -4 you will get, no?
Where, sir?
Here, come up. Here. How much you will get? Joules?
4 joules. 4 joules.
4 joules you will get.
Yes, sir. Because we're squaring it, sir. That's why 4 joules.
Okay. Next here, S1 of t by 2. Next, wait. Pi 1 of t is equal to 1.
S1 of t by root 1.
For 0 to 1. Right, because S1 of t here is what?
S1 of t here is this equation, sir. This graph.
2 you will get. Here it is 2 is there, no?
It's S1 of t by 2
is 1. Okay.
Yes, sir.
Next.
That's what I wrote from seeing from graph. This is 5t of t. This
here -4 you will get.
Yes, sir. -4, yes, sir. S2 -4.
Then
so actually won't be negative, sir. That's why it's positive always, because we're squaring, right, sir? That's why it's 16 joules. It won't be negative.
Okay. S2 of t it is?
S2 of t is this is a negative interval, sir. This
-4
up to 2.
Up to 2. Okay.
That's why this is -1 when we divided by this one, root 4.
Then -1 you will get. Next.
S2 5 3 of t, and this is the equation I wrote, and S32 is -3, S31 is 3.
Okay.
So this is G3 of t, and so I got 3 considering these intervals.
That waveforms you have written pi 1 of t, pi 2 of t, pi 3 of
Yeah,
t.
this one 5 1 of t, 5 2 of 3, 5 3 of 3.
Pi 2 of t, pi 3 of t.
So by observation, I wrote like this: S1 of t is
So
equals
how
to
much marks have you given?
4 marks only, sir.
4. Then I will check. Yours 137.
Yes, sir. 137. Base 17 is 137.
Okay, I will modify it. Okay.
Okay, so the first intent also, so there was some correction in answers. It's like first for one question they have not given options only.
That I told no. We will consider that one at the end.
Sir. Okay, sir. Thank you.
Okay.
Okay, sir. Last question. What should I write, sir? That last question. This one, eighth question. This was given 4.
Hello.
Sir. Eighth question also given 4 marks, sir.
Come down. The board diagram you have written.
Sir. Both diagrams, sir.
Board diagram. I will check up this one. Okay. So you submitted any late submission you have done?
Yes, sir. I told sir network issue over there, so I submitted just 13. I had to go out, sir. That's why 30 minutes late.
30 minutes late, no?
13, sir.
13. Okay.
That was because so network is so lesser here. Geo signals are so poor here, so that's why I have to go out of the station. And
Yeah. Okay. Because that late submission is there, no? For that may be the reason I might have considered that time during valuation. So I will
sir, that's-
consider no problem. You have given
Thank-
reason, no problem. Okay. I
Thank
will do
you.
it. For late submission, I have cut marks actually, 2 marks.
Oh, sir, like sir, he's not in my hands.
No, yeah, but I will consider yours all. No.
Okay.
Because you
Thank
have
you, sir.
given reason, no problem.
Yes, sir.
Okay, thank you for attending this session.
Yes, sir.
Thank you all of you.
Thank you.
Thank you.